Hello everyone, welcome to Neso Academy. In this presentation, we will understand the scope resolution operator. So without any further delay, let's get started with this lecture and let's see what are the topics. The first topic of this lecture is the scope resolution operator. First, we will properly understand the scope resolution operator. Then we will move to the next topic where we will understand some use cases associated with the scope resolution operator. So these are the topics. Let's start with the first one, that is the scope resolution operator. So what is the scope resolution operator? Scope resolution operator is the operator that allows us to access something outside the current scope. In order to understand this definition properly, first we need to understand the meaning of a scope. Now, what is a scope? A scope is a region or area where we can define some entity. We can define a variable, function, or some other entity in a scope, and that specific entity is visible or accessible within that scope only. Now, let's say we want to access that specific entity outside the scope where it is defined, then we can use the scope resolution operator for this purpose. Normally, we cannot access a specific entity which is defined in a scope outside that scope. But with the help of the scope resolution operator, we can access that entity outside its scope as well. So that's what this definition is saying. The scope resolution operator is the operator that allows us to access some entity outside the current scope where it is defined. I hope this is clear to you. Now, this is how we can represent a scope resolution operator. It is represented by two colons, and it also helps resolve which scope a name belongs to. That's why this operator is called the scope resolution operator. It helps resolving which scope a name belongs to. That is, it tells the compiler where to look for to access a specific entity. So that's the scope resolution operator. Now let's see the syntax of the scope resolution operator. We first need to specify the name of the scope, and then we specify the scope resolution operator, and then the name of the entity which we want to access. Now, to understand the syntax properly, let's imagine an example. Let's say we have defined a namespace. Now, within that namespace, we have defined a function as well. In the last lecture, we already learned how to define a namespace and how to define some entity within a namespace. Now, when we define an entity within a namespace, then that entity will have the scope of the namespace where it is defined. Here we are imagining that some namespace is defined, and within that namespace, some entity, let's say a function, is defined. So that function is accessible within the namespace only. Now, if we want to access that function outside the namespace, then we need to use the scope resolution operator. Before the scope resolution operator, we need to specify the name of the scope where the entity is available. This means we need to provide the name of the namespace first. Then after this, we need to provide the scope resolution operator. And after the scope resolution operator, we need to provide the name of the entity which we want to access from a specific namespace. I hope this is clear to you. So in this way, we would be able to access a specific entity which belongs to a specific scope. And this is how the scope resolution operator works. So with this, we have understood the first topic, that is the scope resolution operator, properly. Now let's move to the second topic to understand some use cases associated with the scope resolution operator. Here comes the first use case, accessing global variables. If a local variable hides a global one, use scope resolution operator to access the global variable. So if there is some local variable which we have defined within an entity, and there is some global variable which is defined in the program, which is defined outside of any entity with the same name as the local variable, then the local variable will hide the global variable, and therefore we would not be able to access the global variable within the entity where the local variable is defined. But if we want to access the global variable, then we need to use the scope resolution operator. Now, this can be better understood with the help of an example. Here, I have included the IOStream header file because I'm using stdc out here. And here, I have defined variable x of type integer with value 10. This is the global variable x because this variable is defined in the program and it is outside of any function or any other entity. This variable is accessible to all the entities we defined in this program. So, this variable is also accessible within this main function. So that's why we call this variable a global variable. It is not defined within a function or an entity, it is defined in the program itself. Now here is the main function. Within this main function, I have defined this variable x of type integer with value 5. This is the local variable. Now why am I calling this a local variable? This is because this variable is defined within the main function. This variable has the scope of the main function, and therefore this variable is accessible within this main function only. Whenever we define a variable within a function, that variable is called a local variable. So this variable is local to this function. It has the scope of this function. Now you can observe that the name of the global variable and the name of the local variable is same. So now the question arises that if we try to access x in our main function, then which variable will be accessed? Will it be a global variable or a local variable? Here, in this stdcout statement, I am trying to access the value of x. I have specified x here. Now my question is, will this value will be accessed or this value will be accessed? There is a clash between these two variables. These variables have the same name. Which variable will be accessed? Will it be a global variable or a local variable? The answer to this question is the local variable will be accessed because the local variable takes priority over the global variable. It is always the case. Whenever there is such clash, always the local variable wins. Here I have specified the name x. So clearly we will get value 5 here because the local variable wins over the global variable. So now we know the value of the local variable x will be displayed by this stdcout statement. I hope this is clear to you. Now let's say we want to access this global variable x. Then how do we access this variable? We know that this local variable is hiding this global variable. Whenever we specify x, the local variable wins over the global variable. Now the question is, how do we access this global variable? We can access this global variable with the help of the scope resolution operator. Here I've done this job. Here we have this stdcout statement, and here I have specified the scope resolution operator along with the variable x. Here I'm trying to access the global variable x. From here also it is clear that if a local variable hides a global one, use scope resolution operator to access the global variable. Here I'm using the scope resolution operator to access this global variable. Here we know we get value 10. So we will get the expected outcome from this program. We'll get this output, local x5, then global x10. First, we are getting the value of the local variable. That's what we can see. And then we are getting the value of the global variable. So that's the concept of the scope resolution operator. It allows us to access the global variable if it is hidden by the local variable. Now let's say if we do not have the local variable x, then if we specify x, we will get the access of the global variable because there is no such local variable available in the function. But if we have the local variable which is hiding the global variable, then we need to use the scope resolution operator to access the global variable. I hope this idea is clear to you. So we are done with the first use case. Now let's move to the second use case. The second use case is accessing namespaces. When using names from a namespace, use scope resolution operator to access the name. As I have mentioned this already, if some name or an entity is defined within a namespace, and if we want to access that entity outside the namespace, then we need to use the scope resolution operator. Here is the example to demonstrate the same. I have included the IOStream header file inside this main function. With the help of stdcout, I am trying to display hello Neso on the screen. Now here you can observe that std is the name of the namespace where cout object is available. To access this object outside the std namespace that is within this main function, we need to use the scope resolution operator like this. So it is following the syntax which we have already seen. Here we are accessing cout in the std namespace through the scope resolution operator. Cout object is available in the std namespace. We are trying to access it. I hope this is clear to you. So we have been using std-cout without realizing that we have the scope resolution operator between the two, and this operator is helping us to access this object available in the std namespace. We know the syntax is correct. We will get the correct output. We will get hello Neso as the output. So with this, we have understood the second use case as well. This means we are done with all the use cases of scope resolution operator. And this means we are done with the second topic as well. Okay, friends, this is it for now. Thank you for watching this lecture. I will see you in the next one.